Welcome to my session on Data Integration as a Service. My name's David Eagle, and I'm the FME Division Manager at OneSpatial. Now, many of you will have heard this at conferences before. It's certainly done the rounds, but it's a statement from The Economist from 2017. And whether you believe this rhetoric or not is up to you. But it's hard to deny that certainly we're all walking around with data collection devices in our pockets most of the time these days. And there's a huge amount of data that's out in the wider environment that can enrich our projects as well. But the challenge with that data is extracting from it the information. Unfortunately, quite often what we find is that data sits in particular silos, particular applications and data formats, and departments can often want to share their data, but they find it more difficult than it ought to be to move it between those teams. The classic scenario that many of our customers experience is the CAD to GIS data challenge, moving data from those two environments and between them, handling projections, handling tiling, and filtering and working with that data can be tricky. There are also a great many field collection tools, as well as projects you'll undertake to acquire data, and you have to consider how best to capture that data to ensure its quality. Perhaps you also have back office systems that could really do with being joined up, moving things like timesheet and accounting information to ensure you feed the systems that need to report on that data is vital to ensure you keep a close eye on spend, but also because you need to look after the status of the project. And one of the solutions that you can look at is data integration. And FME is a platform that you can use to be that integration tool. FME fundamentally allows you to have this piece of middleware that sits between you and the recipients of the data and the data itself, and can help you make sense of it and turn it into information. Split it, filter it, merge it together from all of those systems without having to have multiple intermediary steps. So FME forms the data integration component, and it was really positive to listen to Clive Pulse. He's the GIS lead at HS2 a few weeks ago when he presented at one of our events. The link for that recording is at the bottom of the page. Because Clive made a really clear statement. He said, focus on the data. He was making the point that in a huge multi-year infrastructure project like HS2, you have to focus on getting the data right. The right quality, the right structure and schema, the right precision, the right content. Because ultimately the data is what matters. Because you can be sure that in a few years' time, it'll need to be in a new database or a new system, and it'll be being used by new people. So you'd better think about designing the best data you can to give you a fighting chance of it being fit for purpose down the track. FME therefore comes in very handy in these kinds of workflows, because it's all about getting the right data into a structure and a format so that the right people and systems can consume it in the way that it was intended. And there are many organizations in the supply chain and within the wider architecture, engineering and construction industry that are already using FME to connect to their different data formats and environments. FME has support for over 450 data sources, which allows you to move the data between those systems and restructure it along the way. And when it comes to working with data in different arenas, as you can see, over time, FME has added support for different data categories into its collective capability. So in the early days, CAD, GIS and tabular data was a very focused element. But support for 3D environments was brought in, like building information models. And then raster imagery, whether that's data you've captured yourself, or whether it's actually documentation that you want to do things like optical character recognition on to extract features from those documents. That can also be important. The data might be on file servers, but increasingly these days it's in file shares like Office 365, OneDrive. Maybe it's in Azure, or maybe it's on AWS. Maybe that data is a result of making a request via REST to an API. A request to a sensor that's in the field that's capturing real-time information on your particular project site. And ultimately you may want to surface that data in a web mapping system or in a business intelligence tool like Power BI to make sense of the content. If you'd like to know a little bit more about some of the formats that are supported, then just go to the URL listed on the slide below, safe.com/formats, and you'll find out a little bit of extra detail. When it comes to restructuring that data, though, it's important that you make sure that the data is in a structure that will fit the target schema, making sure that it's appropriate. And transformers in FME give you that ability, rather than you having to convert the data multiple times in its life cycle in order to go and do a specific task in, say, Celebri or Revit or over in Excel. You can actually do a lot of the individual restructuring tasks in a continuous workflow within an FME process. And the end game is that you'll be able to automate those tasks. The important thing here is that you can have an external trigger that results in an action downstream. So that might be as simple as dropping a site photograph into a directory. An FME identifies that the photograph has arrived, converts the JPEG to a GIF, georeferences it using the EXIF header information straight out of the photograph, and using that data, it then puts it into a web map. And that eliminates the need to do the manual processing or even the file management. There are thousands of people already using FME around the world, and you're welcome to go and have a look at some of the specific case studies that are relevant to the industries that you're focusing on over on our website at onespatial.com/clients. There's also a lot of partner organisations that integrate their technology with FME. University College London are one of those organisations, and if you've been involved in any large linear infrastructure projects, certainly HS2 being one of the most recently notable in the transport arena, then it'll have been hard for you to have escaped from SnakeGrid. Needless to say, FME does have a SnakeGrid plugin. We sell it, and if you'd like to know more, by all means contact me afterwards, or at the very least go and take a look at Jonathan's presentation that he delivered at our event earlier in the autumn. When it comes to collaboration within the supply chain, there are all sorts of activities that FME can help with, and has historically helped with. The example that I just gave you of doing a directory watch for site photographs was one that Arup put in place. In their case, it was to georeference the photographs to put onto their own internal web map. But it could equally be a system like ArcGIS Online. And that workflow means that not only are you minimizing cost by avoiding, in some cases, sending people out on site unnecessarily if photographs can be easily browsed, but it has the benefit of projects that are very close to one another being able to share this valuable data resource in the form of photographs. But there are scenarios where you just want a simple service to take common file formats and convert them to a format that you want. But if you always get given a DGN from somebody in your supply chain and actually what you'd like is a DWG in some scenarios, then you can upload the DGN and get it back as a DWG in the same structure, but just in a different format. Exactly the same is true about dealing with projection, and Transport for London put in place a process that allowed them to upload a file in a format and get back the very same format, but they'd submit it in British National Grid and get it back in London Survey Grid, or vice versa. So a very simple reprojection as a service concept. There's also the requirement sometimes to go and do some sort of desk-based study. And in scenarios like this, conflating a package of data is handy, especially if you can use a one-stop shop tool to do it. Using a tool like GeoCortex, it's very easy to generate an area of interest and then go and request from several different formats data to be exported to cover your area of interest and download it as a package. And then you've also got capabilities like site inquiry. And we have a number of land management firms that do, as I mentioned a moment ago, desk-based studies to make sure that they understand the location they're going to well in advance of actually arriving on site. So you can do what's my nearest or what's here kind of inquiries in a particular location, and then get back a queried inventory of assets that are on the ground to go and understand before actually leaving the office. Now, when it comes to deployment options, there are plenty of them. The first of these being perhaps the more traditional on-premise approach, where you can take an FME license, deploy it yourself, put it on your own IT environment, and go and connect to the data that you have stored locally. Or we can help you do that for you. We've just completed a deployment for the Environment Agency and provide them with a managed service around their FME ETL, or extract, transform and load capability. Then there's software as a service, where we can provide you with FME as a completely managed cloud service. The beauty of this approach is that it allows you to innovate, because we can provide you with an instance on the same day if required, so we can host it, you can do rapid prototyping, and you can build an app. We can set up scheduling so that the machine can turn itself on and off at different times of the day or the week, and you can just pay for what you use or get some economies of scale from a subscription. And lastly, there's a platform as a service approach, where you can provide us with your private cloud environment onto which we can help you deploy your ETL solution. One of these deployments, actually in this case with the addition of provisioning the platform as well, was for Fusion JV. And I'd like to conclude myself by welcoming and handing over to Chris Couchman of Fusion JV to explain a little bit about what they've been doing with the platform. Over to you, Chris.
Thank you, Dave. Just a bit of background information regarding Fusion. Fusion is a JV mainly incorporating 3 main companies. This is Fraval Agroman, BAM and Morgan Sindall. We are working on enabling works for 100 kilometres of phase 1 for HS2. We've been using FME from OneSpatial for over a year. The system has become essential to our BIM GIS data management framework. This slide shows the usage of FME server within our framework. The chart on the right shows we are averaging around 80 to 90 jobs per day. This will increase over time. This includes both self-serve and scheduled jobs. The pie chart on the left shows different areas of business that these workflows cater for. Important to note, highlighted in red, we use workflows for non-spatial GIS data for dot control as well as GIS data. I will go through in a later slide. This is an example of a simple but important self-serve job. Self-serve enables the user to instantly run jobs themselves via a browser once created by the Fusion GIS team. Therefore, the user does not need to wait for a GIS person to do the workflow for them each time they require a data transformation of some description. Also, this saves the need for an army of GIS people, which is not cost effective. This is a simple workflow that converts data to a snake grid coordinate system, which is utilized a lot. Snake grid is a linear coordinate system used by HS2. As mentioned earlier, we use FME lots for non-spatial data within dot control. Here is an example where we use FME for data validation. The user can submit a MIDIP, which is essentially a spreadsheet of asset information. Once submitted, a number of data quality checks are performed regarding if data has been inputted correctly and in the correct format. An email is then sent to the user to show if MIDIP has passed validation. This means manual checks are not required, and user has confidence if passed, the MIDIP will be accepted by HS2 upon submission. The chart on the right utilizes FME dashboard and visually shows the status of submissions for each workflow, code 1 green being approved. This again shows the capability of the FME dashboard, showing statuses of different HS2 submissions within a visual format. The CAL process, which I mentioned earlier, stands for Consolidated Outstanding Worklist, is a process where FME is fully integrated within a GIS data capture workflow. CAL is basically a process where maintenance activities required are recorded, e.g. we have a broken fence and it needs to be fixed. FME enables us to automate many attributes regarding data entry, for example in this case creating of the ID, performing spatial intersects where the asset is, and automating emails to different people based on the area of concern. This all alleviates the chances of data error if manual data entry was performed instead. Moving forward, we aim to use FME more for automating data entry within a number of our data management workflows. We also want to use FME more for data collaboration with our main works partners. Thank you very much.
Thanks for that, Chris, and thank you everybody for listening to this session. I hope you enjoy the rest of the day.
Thank you, gents. Very informative. Really appreciate your presentations there. I'd like to ask you to join us on stage. Thank you. Hi, Chris.
Hiya.
And as Dave joins us as well. We've got a couple of questions. I've also got one question I'd like to ask, because it came to mind. Chris, you mentioned you're using FME and you're using it for last year. What type of deployment have you got? I suppose that's the first one. The second one is you're talking about potentially using it to increase collaboration and improve data entry. It'd be good to hear a bit more about your desires and aims there.
Yeah, so obviously we do enabling works, and we collaborate a lot with main works. So there's an awful lot of data that's going in between the two of us. So already in our system, we probably have 600 plus data sets. Main works need to know what the status of the works is, what's in certain areas. So if there's badges or or newts or archaeology. So it's essential that the data that they see is correct and up to date, and have view of all the data that are available. We initially were using FME desktop. As I think mentioned in the slide, we found that people were asking us to do an awful lot of transformations that we don't have the resources for. We were just getting overloaded. So with the FME server deployment that One Spatial host for us, it's enabled to give the user more power to run the jobs themselves.
Okay, and sort of gives them self-serve capability.
Yeah, definitely. We also do a lot of scheduled jobs as well. So moving data around on a scheduled basis. There is still some data silos where obviously we need to put data into the CDE. So it's one source of truth, which we all know about. But because of the amount of data sets available, FME server helps a lot. And to be honest with you, without it, we'd be constantly firefighting, I think.
Yeah, interesting. Okay, well, it's a classic example of automation making people's lives easier, or at least giving them more time to do other work.
Yeah.
Okay, there's a couple of other questions here. I'm conscious of time. I think this is one for Dave, actually. You've been involved, have you been involved in any projects where location or real-time positional data was the key to gluing together the people and systems involved? And that's kind of, I suppose, following on from what Chris was talking about, how FME's been used as that glue to tie systems and people together.
Yeah, thanks, Mark. Yeah, we got involved with a client a little while ago. They were a electricity utility company. They were doing an offshore cable trenching project, and they approached us because they'd got an ArcGIS Online platform that had got all of their asset data in it, but they were just missing one vital piece of the jigsaw, and it was vessel tracking data. They had a bunch of operational vessels who were doing the cable laying. They had an inspectorate vehicle that was checking up on them, and they needed their operational system to be enabled with that real-time vessel data. So it was one of those projects where they approach you with a week's deadline. So we had a pretty quick turnaround. We used FME Cloud, created the platform, built a little process for them. They wanted to use marinetraffic.com, which, for anyone who's interested, is a bit of a boat spotter's dream. It's a really interesting website. Shows you lots of vessel activity that's being real-time issued. Those of you who saw the recent sort of Southampton vessel hijacking a couple of weeks ago, you could actually go and look at the position of the boat as it was moving around. But we use that API. FME can hit an API, grab the data. We ran a single process every 2 minutes to grab the vessel data from the fleet and load ArcGIS Online. It ran every 2 minutes for 3.5 years without a hiccup. Millions of records. We had real-time data going into ArcGIS Online and updating that system, and we put a full archive into a system, well, an environment called Google Fusion Tables, which has been retired by Google now, but back then it was a complete freebie. So we used that as an archiving resource. So yeah, really interesting project, and it was literally just the missing piece for them. So.
Okay. Touching into the world of IoT there, isn't it?
Yeah.
Thank you for that. Well, we're coming to the end of this session. Chris, I'd like to say thank you for your presentation. Dave, thank you as well. Appreciate it. I'd like to